Okay, welcome to electrical machine lecture. Continue. We'll continue the same topic, that is speed control of DC motor. So for today's the numerical is 7.46 kilowatt, 220 volt, 900 RPM. Motor has full load efficiency of 88% and armature resistance of 0.08 ohms and shunt field current of 2 ampere. If the speed of motor is reduced to 450 rpm by inserting a resistance in armature circuit, the load torque remain constant. Find the armature current and external resistance value to be placed in the armature circuit. So here the given data is the motor rated output, say P output power is equal to 7.46 kilowatt. So it is 7.46 into 10 raised to 3 watt. This is the power output and it is running at speed N1 is equal to 900 RPM. Okay. Now it is a DC shunt motor. So here we will draw the diagram for the DC shunt motor. Now we want to say it is the initial speed is 900 rpm and we want to reduce the speed to 450 rpm. The meaning is that this is the problem for armature control. So we have to put a resistance in series with the armature to reduce the speed for the required value. So this is the armature circuit and a external resistance is connected in series with the armature circuit, whereas the field winding remain as it is, means there is no change in the field current. So the flux in the shunt field, flux in the motor is constant. So it is ISH and this is the armature current IA, the external resistance lit R, this is motor and it is applied 220 volt. So this is positive negative supply voltage. Now where the armature resistance is given as RA is equal to 0.08 ohm, whereas the shunt field current is given, it is 2 ampere. So ISH is given, it is a 2 ampere. If the speed of the motor is reduced to 450 rpm, means the speed in the second case it's 450 rpm, it is given. The torque is remain same. The torque TA1 is equal to TA2. Torque is torque TA2. The torque is remain same. That's why the armature current, because torque is directly proportional to, it means that armature current IA1 is equal to IA2. Okay. Now, first of all, we have to calculate the current drawn by motor. So the load current the current I. So current I is equal to power output 7.46 into 10 raised to 3 divided by the rated voltage. It is 220 volt. So it is equal to 38. Uh, it is the output power. So multiplied by the efficiency. Okay, we will write one more step. So power input is equal to power output divided by efficiency. So it is 37.46 into 10 raised to minus 3. Sorry, it is 10 raised to 3 by converting the power kilowatt into watt divided by point. The efficiency is 88%, so 0.88. This is the power input. So we can calculate the current drawn by motor. I is equal to output divided by voltage. So it is 7.46 into 10 raised to 3 divided by 220 volt multiplied by 0.88. So the total current is 38.5 ampere. So this current is 38.5. 2 ampere is going to flow from the shunt field winding. Therefore, armature current IA1, which is equal to 38.5 minus 2, it is 36.5 ampere. And we have already considered the torque TA1. Armature current is torque is same. So torque is same. So the armature current in the second case also be the same. So now back EMF EB1 is equal to, or see, we can write as the torque is same. So armature current is same, already taken. V minus IA into bracket into RA. So it is equal to 220 minus 36.5 into 0.88. It is 0.08. 0.08. 0.08. It is equal to the back EMF in the first case is 217.1 volt. Whereas back EMF EB2, which is equal to V minus armature current IA2 into RA plus R, the external resistance. So it is 220 minus 36.5 into bracket 0.08 plus R. This is the value. As we do not know the second case, so we will keep is as it is, or we will put the value 220 minus 36.5 and say the total resistance is RT, where RT is equal to the armature resistance 0.08 plus external resistance to be inserted to obtain the required speed. Now we know, or we know the relation N2 upon N1 is equal to EB2 upon EB1. Therefore, EB1 we can calculate, EB2 we can calculate. EB2 is equal to N2 is the speed in the second case. It is equal to 450 RPM. Okay, multiplied by EB1, it is 217.1 volt divided by N1, it is 900 RPM. So it is a 900 RPM. So EB2 is the value. Now put the value of EB2 into this equation. So EB2, we know that EB2 is equal to 220 minus 36.5 into RT. And if you put the value of EB2, we get total resistance RT is equal to, it is 3.05 ohm. Therefore, the external resistance resistance to obtain or to get speed 450 rpm, R is equal to 3.05 minus 0.08 ohm, and it is equal to resistance, external resistance is 2.97 ohms. So this is the first. Now second example, a DC shunt motor drives centrifugal pump whose torque varies as square of speed. The motor is fed from 200 volt supply and takes 50 ampere when running at 1000 rpm. What resistance must be inserted in the armature in order to reduce the speed to 800 rpm? So again, this is the DC shunt motor, and we have to insert resistance in the armature circuit. So it is the armature control method where we have to put the resistance in series with the armature circuit. So this is the motor where we have connected external resistance in series with the armature. So when we are connecting the resistance in series with the armature, the speed is going to drop, or the speed control will be the below normal value. So here the voltage across field winding is constant. So it is 200 volt supply voltage. Whereas the motor takes 50 ampere and running, the speed in the initial condition is 1000 rpm, and we want to bring the speed down. N2 is equal to 800 rpm. Where the armature resistance is given as, here armature resistance is given as 0.1 ohm, and shunt field resistance RSH is given 100 ohms. Okay. Any more data? Yes, this is the data. Now, in this case, the shunt field current ISH, so the shunt field current ISH is equal to 200 divided by 100, it is 2 ampere. Shunt field current is 2 ampere. Therefore, the armature current IA1 in the initial condition, IA1 is equal to I minus ISH, it is equal to 50 minus 2, 48 ampere. So this is the current in the first case. Now what is given? It is given that the torque uh, the torque varies as the square of speed. So it is given that torque is vary square of speed. It is given that for the for given centrifugal pump. It is the it is given for the centrifugal pump, and we know that the torque is directly proportional to flux into armature current. Since flux is constant, why it is constant? Because there is no external resistance inserted in series with the shunt field winding. So the shunt field current remain constant and torque is directly proportional to armature current, and as per given, it is directly proportional to square of speed, isn't it? So we can say that from this one, uh, we can obtain the current in the second case. So here it is T1 upon T2 upon T1 is equal to say I2 upon I1. TA2 upon TA1 is equal to IA1 upon IA2 upon IA1. Okay. So if you replace this relation, so we can obtain the N2 upon N1 bracket square, as the torque is varies with respect to the square of speed, it is IA2 upon IA1. Now put the values of speed, it is 800 divided by initial speed is 1000 rpm bracket square is equal to I2 we want to know divided by current IA1, it is 48 ampere, and from this one we can calculate IA2 is equal to, by this one it is IA2, it is equal to 30.72 ampere. Now once we know the value of IA1 and IA2, we can calculate back EMF 1, it is equal to 200 minus 48 into zero point 0.1. So it is equal to 195.2 volt, whereas EB2 is equal to 200 minus the current 30.72 into RT, where RT is the total resistance in the armature plus external resistance. Now N2 upon N1 is equal to EB2 upon EB1. Therefore, if you put the values, EB2 equals to EB2, or directly if you put the value in such a way that we can calculate N2 is equal to 800 rpm divided by 1000 equals to 200 minus 30.72 RT divided by 195.2 volt. So the EB2, we can calculate the total resistance RT equals to 1.42 ohms, and therefore external resistance R, by subtracting the value 0.1, it is 1.32. So this is the so here. Now the next example is a 240 volt DC series motor takes 40 ampere. So it is a series motor when giving its rated output at 1500 rpm. Its resistance is 0.3. Find what resistance must be added to obtain the rated torque at starting and at 1000 RPM, when the speed decreases to 1000 RPM and at the time of starting. Okay. Now, for that purpose, what is the motor is taking? DC motor takes 40 ampere. Okay. So we can say that if R is the resistance, R is the series resistance added, then 40 is the current, 40 is equal to 240 volt divided by armature resistance is 0.3 and external resistance is say R 0.3. So the external resistance R is equal to 5.7 ohm. Okay. Now current is remain same. Current is as it is given. Current remaining same. Same. Sorry, remaining constant or okay, same. We can say that torque is directly proportional to back EMF divided by speed. So we can write as EB1 upon N1 is equal to EB2 upon N2. So here EB1 and EB2 we can calculate. EB1 is equal to 240 minus 40 into 0.3. So it is equal to 228 volt. Whereas EB2 is equal to 240 minus the current is same 40 into R plus 0.3. Okay. And whereas here the speed is given N1 is equal to 1500 RPM and N2 is 1000 RPM. So by calculating, we can calculate N2 upon N1 or EB2 or EB1, or you can write as a EB1 upon from this formula, the ratio which already used in the most of the numerical. So we can calculate the resistance R. Okay, it is N2 upon N1 is equal to EB2 upon EB1. Put the values. First calculate the value of EB2, and from this EB2 we can calculate the resistance R. So here resistance R is 1.9 ohm. So this is the answer. So okay, so next time again we will meet with some more numerical, practice numerical based on the speed control. Thank you.